The American Southwest enters monsoon season in 3 weeks, sitting on the driest soil in 1,200 years. When the thunderstorms collapse, the outflows will build dust walls a mile high, single inhaled spore. Last year, it sent roughly 14,700 people to Arizona doctors. The actual number of infections, per a study published this June in JAMA Network Open, may be 18 times that. The deaths from the dust itself, 232 in 11 years, were hidden in federal databases, filed under high winds and thunderstorms, until a researcher cross-referenced the records. And the systems protecting 5.2 million people in Metro Phoenix were designed for a desert that no longer exists. If the connection between a dying lake and a lung full of fungal spores just got you locked in, take a second and hit subscribe to Orbital View. We're tracking the Southwest compound crisis as monsoon season opens. Drop a comment. Have you driven I-10 through a dust wall? I read every one. Here is what this investigation covers. A millennium-scale drought that has drained the reservoirs protecting 40 million people to levels not seen since the 1930s. A wall of dust taller than the Empire State Building, carrying particles so small they bypass every filter your body has. A fungal pathogen whose endemic zone is expanding toward the Canadian border, and a health system that has never been stress-tested against all three arriving on the same afternoon. Let's get into it. Part 1. The desert that no longer exists. I want to start with a number, and I need you to sit with it for a second before we move on. 1,052 feet. That is where Lake Mead stood as of the 1st of June, 2026. If that number doesn't land immediately, here's the context. Lake Mead is the largest reservoir in the United States, a body of water that stretches more than 100 miles behind Hoover Dam. More than 40 million people depend on the Colorado River system it anchors, cities, farms, power grids, entire economies stretching from Denver to Tijuana, and 1,052 feet is within striking distance of the lowest water surface elevation since the reservoir first filled in the 1930s. In mid-May, 8 News Now reported the lake dropped below 1,050 feet, heading toward its lowest level in 90 years. The Bureau of Reclamation's May 2026 projections model Lake Mead reaching approximately 1,037 feet by the end of December, which would fall below the 2022 record low of roughly 1,040 to 1,041 feet. If that projection holds, the bathtub ring around the canyon walls, already hundreds of feet tall, already visible from orbit, will be the widest it has ever been in the reservoir's existence. But the lake is a symptom. The disease is what is happening to the soil beneath your feet. The U.S. Drought Monitor, a joint product of NOAA, USDA, NASA, and the National Drought Mitigation Center, so not a fringe estimate, reported that as of June 2, 2026, 58.38% of the lower 48 is in drought, nearly 6 in 10 acres of the contiguous United States. Extreme to exceptional drought, D3 and D4 on the 5-category scale, the darkest reds on the map, is entrenched across the West. 1 week earlier, the figure was worse, 60.77%. And here is where the heat enters. The National Weather Service office in Phoenix, NWS Tempe, confirmed that spring 2026 was the hottest meteorological spring on record for Phoenix, Yuma, and El Centro. Not the hottest in a decade, on record, driven by historic March temperatures that rewrote the local climate database. On June 6th, the day before this script, NWS Phoenix had a red flag warning in effect for southwest Arizona and the lower Colorado River Valley. Very low relative humidity, dry fuels, gusts to 35 miles per hour. So picture what this looks like from above. Record heat-baking soil that has not received adequate moisture in over 2 decades. The Bureau of Reclamation's May 2026 24-month study projects, Lake Powell, the other anchor reservoir on the Colorado, ending the water year near 3,511 feet, about 20% of capacity. Total Colorado River system storage, 357,000 acre-feet, 35% full, down from 40% a year ago, and the unregulated inflow to Powell this water year is forecast at 3.27 million acre-feet, 34% of the long-term average. Think about what that means at the ground level. The soil is not a sponge anymore. It is a parking lot. Rain falls on it and runs. Wind hits it and it lifts. Every arroyo is cracked. Every playa is exposed. Every acre of what used to be lake bed is now bare alkaline sediment waiting for a gust. And monsoon season, the period when thunderstorms build over the desert and collapse, driving outflow winds across all that loose surface, starts in 3 weeks. And the fire season is already compounding on top of all of this. Per the National Interagency Fire Center's June 5th SUTREP, 2026 is running roughly 140% of the 10-year average for fire starts, about 30,588 fires so far, and 195% for acreage, approximately 2.4 million acres burned. The Seven Cabins fire on the Lincoln National Forest in New Mexico, started May 14th, was the nation's largest active fire at nearly 32,000 acres and only 57% contained. AccuWeather projects 5.5 to 8 million acres nationally before the year is out. Fire and dust feed on the same conditions. Drought-stressed vegetation burns faster, burns hotter, and leaves behind bare soil that the next wind event can loft into the atmosphere. And here is the atmospheric twist that most coverage is missing entirely. The Climate Prediction Center currently forecasts El Niño persisting into fall and winter with greater than 95% confidence. The North American monsoon, the seasonal pattern that brings thunderstorms to the southwest from July through September, is expected near to above normal. More monsoon storms sounds like relief. It is not, because monsoon thunderstorm outflows over desiccated soil are the engine that builds haboobs. A stronger monsoon hitting the driest surface in a millennium does not mean less dust. It means more powerful outflows slamming into more exposed ground. I'm going to prove something to you over the next 2 hours. Every physical precondition for catastrophic dust storms, the kind that kill on highways, that blind airports, that seed human lungs with spores capable of reaching the brain, is active across the American Southwest right now. The Metro Phoenix population, 5,228,938 people, as of the Census Bureau's March 2026 estimate, the 10th largest metro in America, 4th nationally for numeric growth, sits directly underneath those conditions, and the systems designed to protect them were built for a desert that no longer exists. Part 2, the wall. To understand the threat, you need to understand what a haboob actually is. And I am not going to start with the textbook definition. I am going to start with what it looks like from the ground at highway speed. Imagine you are driving west on Interstate 10 outside Phoenix. Clear sky ahead. Then you notice a brown line on the horizon, too low for clouds, too solid, too uniform. It looks like a mountain range that was not there 5 minutes ago, and it is moving toward you. That is a haboob. The word comes from the Arabic for to blow. Per the American Meteorological Society's Glossary of Meteorology, it originated as a description of storms in northern and central Sudan, especially around Khartoum, where the average number is about 24 a year, most frequent May through September. But the physics is universal, wherever monsoon-type thunderstorms collapse over dry, exposed soil. Here is the mechanism, and I want to explain it without jargon, because the mechanics are what make these storms so hard to outrun. A monsoon thunderstorm builds through the afternoon. It matures. The updraft that held it together weakens. And then the rain inside the cloud, sometimes the rain that never reaches the ground, evaporating on the way down, drags air downward in what amounts to a column of cold, dense atmosphere slamming into the earth. Meteorologists call this a microburst or a downdraft. When that column hits the surface, it cannot go down anymore, so it goes out. It spreads in every direction, fast and flat, and the leading edge of that outflow races across the desert floor, scooping up every loose particle it touches and stacking it into a wall. Think of it this way. You have watched someone drop a water balloon on pavement. The splash radiates outward in a disk. Now scale that up. The balloon is a collapsing thunderstorm. The pavement is the Sonoran Desert. And the splash is a wall of dust reaching a mile into the sky, advancing at 30 to 40 miles per hour. That is not dramatized. On July 5, 2011, Phoenix experienced one of the most thoroughly documented haboobs in modern history. NWS Phoenix estimated the wall reached 5,000 to 6,000 feet, roughly a mile high. Its leading edge stretched approximately 100 miles wide. It traveled more than 150 miles, and the outflow gusts behind it exceeded 70 miles per hour. Davis-Monthan Air Force Base in Tucson clocked 72 on its anemometer. Mike Olbinski's time-lapse from that evening went globally viral, and it matters for a structural reason, because that footage is the reason most Americans have a mental image of a haboob at all. Before 2011, the word barely existed in the American public vocabulary, and the thing is, 2011 was not a one-off. August 25th, 2025, just last year, another major haboob hit the Phoenix metro. More than 60,000 customers lost power. Sky Harbor International Airport, the 11th busiest airport in the United States, issued a ground stop lasting roughly an hour. More than 200 flight delays. Terminal 4 sustained roof damage. 70-mile-per-hour gusts shredded a connector bridge. That same weekend, a dust storm hammered Burning Man in Nevada's Black Rock Desert. NWS forecaster Mark O'Malley noted that monsoon rain being very hit and miss, with Phoenix staying drier than the surrounding areas, is typical for a monsoon. Typical. And 60,000 people lost power in August heat. The National Weather Service issues 3 tiers of dust alerts, and knowing what they mean matters. A dust storm warning goes out when visibility drops to half a mile or less, with wind speeds at or above 30 miles per hour. A dust storm watch signals those conditions are likely. A blowing dust advisory covers lesser visibility reductions. Researchers at Arizona State University, led by Ryan Heinzman, spent 5 years developing the first standardized dust storm scale, an attempt to classify these events the way the Fujita scale classifies tornadoes. Because right now, a haboob that kills 3 people and one that merely dirties windshields are filed under the same warning product. But here's the part the footage cannot show you. What is inside the wall? Rahman and colleagues published a study in Atmospheric Environment in 2014 analyzing EPA station data from that night. Peak hourly, PM10, particulate matter 10 micrometers or smaller, the fraction that penetrates deep into your lungs, hit 1,974 micrograms per cubic meter. Egar and colleagues, in a follow-up analysis in 2017, found the 5-minute peak was closer to 9,000 micrograms per cubic meter. The EPA's 24-hour safety standard for PM10 is 150. So in a 5-minute window, the air in parts of Greater Phoenix carried 60 times the daily safety threshold. And you can verify the satellite picture yourself. NASA's Terra and Aqua satellites measured aerosol optical depth, above 0.8 over the Phoenix Basin on July 6, 2011, using the MODIS sensor. Calypso's LiDAR gave a vertical cross-section showing the dust plume stacked nearly 2 kilometers high. The Schweiss split back trajectory model traced the source to the outflow's origin across the desiccated basins south of the metro. And I want to park on a nuance here because it changes the risk picture. A study of 93 convective dust events from 2015 through 2021 found that only about 15% exceeded the EPA daily PM10 threshold. Most haboobs, measured across a full day, do not look that dangerous in the aggregate data. They blow through. The daily average stays below the line. But the hazard is not in the daily average. The hazard is in those 5 minutes, those 30 minutes, where the air you are breathing is functionally unbreathable. And if you happen to be outside, on a highway, on a work site, in a tent, the distinction between the 24-hour average and the 5-minute peak is the difference between a weather event and a body bag. Hold that gap between the average and the peak. It comes back later, and when it does, it restructures the entire conversation about who is actually protected and who is not. Part 3. The kill zone on Interstate 10. I have to take you to a specific stretch of highway before I go deeper into the biology, because the biology is where this investigation ultimately lands, but the most immediate lethality, the one that can kill you this afternoon, lives on asphalt. Interstate 10, Mileposts 175 through 215, between Phoenix and Tucson, through the open desert south of Casa Grande. Arizona first responders know this corridor by reputation. December 22, 2009. A dust storm rolls across the highway. Visibility collapses, not reduced, not impaired, gone. 22 vehicles pile into each other in a chain that took seconds to build and hours to clear. 3 people die: Mark Eid, 14 years old, and his sister Katie Eid, and Edgar Ivan Medina Vargas, age 25. 12 more injured. The storm did not last long. Neither did the time between seeing nothing and impact. At highway speed, you cover 100 feet per second, 0 visibility, and 100 feet per second. Do the arithmetic on that, and you understand why these pileups happen. March 1st, 2025, near Tonopah, about 50 miles west of Phoenix. Another dust wall, another multi-vehicle crash. At least 4 dead. NWS had issued numerous dust storm warnings beforehand. But the warnings do not change the physics of a vehicle traveling 70 miles per hour, entering 0 visibility. Over the past decade, 36 people have died in dust-related crashes on Arizona highways. The State Department of Transportation runs a public safety campaign with a slogan that doubles as a survival instruction: pull aside, stay alive. Because the alternative, braking or stopping in a travel lane you can no longer see, is how multi-car chain reactions start. And just recently, May 2019, 2026, KUNM reported on recurring deadly storms over the Lordsburg Playa at the Arizona-New Mexico border. A 2025 storm there caused an 11-car pileup and 3 deaths. Rural Hidalgo County, New Mexico, population roughly 5,000, hired 3 additional sheriff's deputies at a cost of about $265,000 a year, specifically to manage the burden of dust storm responses on their stretch of I-10. That is a tiny county spending a significant fraction of its budget because dust keeps killing people on the highway running through it. But here's the number that made me stop and reread the page twice. Daniel Tong at George Mason University, also affiliated with NOAA, published a study in the Bulletin of the American Meteorological Society in 2023. The question: how many Americans actually die from windblown dust events? The answer, it turns out, depends on who is counting and how they file the paperwork. NOAA's official natural hazard statistics, the database that policymakers rely on, had been undercounting for years. Some dust fatalities got classified under high winds, some under thunderstorms. The dust disappeared from the record. Tong's team cross-referenced multiple federal databases, including the Fatality Analysis Reporting System, and found 232 deaths from windblown dust events between 2007 and 2017. That is roughly 5 times what NOAA's hazard statistics showed. The deaths were there. They were just filed in the wrong drawer. And this connects to something I keep encountering in this investigation, a structural problem that is not conspiracy, it is classification. The data exists. The deaths are counted somewhere. But the way institutions categorize hazards splits the dust signal across multiple databases and multiple agency jurisdictions. And the people making decisions about highway design, warning systems, and public health funding never see the full picture assembled in one place. They are working from the smaller number. Always. And the smaller number is the one that does not justify the spending. This is the kind of gap, not a gap in knowledge, but a gap between what is known and what is acted on, that runs through every layer of this investigation. The atmosphere is not hiding anything. The data is right there on the servers of NOAA, the EPA, the Census Bureau, and ADOT. What is missing is the assembly, the picture that forms when you lay the drought data next to the dust data, next to the highway, data next to the hospital capacity, data next to the fungal surveillance data. And that picture is what the next hour and a half is going to build. At part 4, the dust is getting worse and we can prove it. So the storms are dangerous. The highways are vulnerable. The peak exposures far exceed safety thresholds. But is this actually getting worse? Or is it just getting more attention because more people live in the path? This question matters because the answer determines whether what I am describing is a stable hazard that we simply need to manage, or a hazard that is intensifying on a trajectory the management systems have not caught up to. And the data is clear. In 2017, Tong and colleagues, spanning George Mason, NOAA, and several partner institutions, published in Geophysical Research Letters a finding that should be far more widely known. Wind-blown dust storm frequency across the American Southwest increased 240% from the 1990s to the 2000s. 20 events per year became 48. That is not a detection artifact. They controlled for changes in observational coverage. The storms are increasing because the land surface is changing underneath them, and the land surface is changing because of what Park Williams and his team proved. Williams at UCLA, with co-authors at Columbia's Lamont Doherty Earth Observatory, and NASA, published in Nature Climate Change in 2022. The current Southwest drought, running continuously since the year 2000, is the driest 22-year period since at least 800 CE. Not the driest century, the driest in over 1,200 years. They established that using tree ring reconstructions of soil moisture extending back to the 9th century, cross-validated against modern satellite data. Williams said something I have not stopped thinking about since I read it. The drought, he said, is not petering out. Instead, it is in full swing and is as strong now as it ever was before. He added that it is extremely unlikely that this drought can be ended in one wet year. His co-author, Jason Smerdon, described the mechanism in plain terms. Warming creates a thirstier atmosphere that pulls moisture from soil and vegetation. The hotter the air, the harder it drinks from the ground beneath it, and the human fingerprint is quantified. Williams's team attributed roughly 42% of the soil moisture deficit to human-caused climate change. That is not an activist number. It is a peer-reviewed attribution figure published in one of the most rigorous journals on the planet. The consequence for dust is direct and physical. Drier soil means looser soil. Looser soil means more material available to be lofted when outflow winds arrive. The West has measurably become dustier. Researchers have tracked increased calcium in rainwater, heavier dust loading on Rocky Mountain snowpack, accelerating melt, and a documented acceleration of locally generated dust events. Benjamin Cook at NASA and Columbia projects continued drying across the Southwest through the century under virtually all emission scenarios. Frederick Preen's work corroborates. The models agree on the direction, even when they disagree on the magnitude. Since 2000, the average soil moisture deficit has run twice as severe as any drought of the 20th century. Williams's team ran simulations to test the drought's persistence. In 94% of those runs, it lasted at least 23 years. In 75%, it lasted at least 3 decades. This is not a dry spell waiting for one generous winter to break. It is structural. The soil has crossed a threshold where even normal precipitation years cannot recharge the deficit because the warmer atmosphere pulls the water back out before the ground can store it. So when I tell you that the 2026 monsoon season is about to open over the driest, hottest, most exposed soil surface in over a millennium, with fire season already running 140% of the 10-year average for starts and 195% for acreage per NIFC, that is not dramatic framing. That is the peer-reviewed baseline. And the monsoon outflows about to collide with that surface are the engine that builds Haboobs. But the dust itself, the particles, the chemistry, what is living inside that wall, is where this story pivots from a weather investigation into something most people are not prepared for. And the pivot starts with a fungus that has been sitting in the top few inches of desert soil for millennia, waiting for exactly the kind of disturbance a Haboob provides. Part 5, the spore in the soil. There is a disease in the American Southwest that sends roughly 20,000 people to a doctor every year. It hospitalizes thousands. It kills hundreds. And the best current estimate of its true scale, published in JAMA Network Open in June 2025 by Williams and colleagues, suggests somewhere between 206,000 and 360,000 symptomatic infections per year, 10 to 18 times higher than what surveillance captures, because the disease is reportable in only 28 states, because it mimics bacterial pneumonia so convincingly that it accounts for roughly a quarter of community-acquired pneumonia diagnoses in endemic areas. And because most physicians outside Arizona and California have never been trained to consider it. The disease is called coccidioidomycosis. Most people call it valley fever. And before I go further, the economic dimension is staggering. A cost of illness study published in Open Forum Infectious Diseases in 2021 calculated that the per person lifetime direct cost of uncomplicated valley fever pneumonia, which accounts for about 85% of cases, is roughly $23,200. Chronic pneumonia, $130,000. Disseminated infection, the kind that reaches your brain or bones, $1.26 million per patient. Statewide direct cost in Arizona alone, $671 million. And those numbers are from before the record-breaking years of 2023 and 2024. The pathogen is a soil fungus, two species, Coccidioides immitis and Coccidioides posadaceae. They live in the dry, salty, alkaline soils of the desert southwest, often concentrated around rodent burrows. Their distribution is not even, it is focal. One patch of ground can be loaded with the organism. The patch 10 feet away might be clean. And when the soil is disturbed by wind, by a bulldozer, by an earthquake, by a haboob, the fungal filaments break apart into barrel-shaped spores called arthroconidia. Here is the dimension that matters more than any other in this story. Each arthroconidium is 2 to 5 micrometers long. A human hair is about 70 micrometers wide. These spores are roughly 35 times smaller than the width of a hair. They are small enough to bypass your nose, to sail past your trachea, to slip through the branching airways of your lungs, narrower and narrower, all the way down to the terminal bronchioles and the alveoli, the microscopic sacs where oxygen crosses into your blood. A single spore can cause infection. 1. Once it reaches the lung, the organism transforms. It swells into a sphere 60 to 100 micrometers across, packed with endospores. And when that sphere ruptures, it seeds the surrounding tissue with a new generation. Your immune system now has a fight on its hands it was never designed for. About 60% of infected people never develop symptoms. Of the 40% who do, most experience what feels like a severe flu, fever, cough, crushing fatigue, joint pain, severe enough that early physicians called it desert rheumatism. It is frequently misdiagnosed as bacterial pneumonia, and this is not a rare diagnostic error. Valley fever accounts for approximately 1/4 of community-acquired pneumonia cases in endemic regions. Patients get prescribed antibiotics that do nothing. Weeks pass, sometimes months. 5 to 10% develop serious or chronic lung disease that can crater a life, and roughly 1% disseminate. That word means the fungus escapes the lung entirely and spreads through the bloodstream, to skin, where it erupts in lesions, to bone, where it eats through structure, to the lining of the brain, where it causes a meningitis that can be fatal, and when it is not fatal, can require antifungal medication for the rest of the patient's life. There is no vaccine. There is no quick test that catches it in an urgent care waiting room. The average time from first symptom to correct diagnosis in valley fever is measured in weeks to months, and every week of delay is a week the fungus has to dig in deeper. The numbers from 2024 are stark. Arizona reported 14,763 cases, 986 hospitalizations, 86 deaths. The Arizona Department of Health Services flagged that up to 800 cases may reflect false positives from a faulty test kit used before April. But even correcting for that, the trajectory is unmistakable. Arizona alone accounts for more than half of all U.S. valley fever cases. And University of Arizona Valley Fever Center researchers, including John Galgiani and Fariba Donovan, attribute much of the rise to something that sounds reassuring but is not: increased clinician testing. More doctors are looking for it. They are finding it because it was always there, undiagnosed. California is surging in parallel. The state health department reported approximately 12,637 cases in 2024, also a record. First quarter 2025, 3,123 cases, triple the first quarter of the prior year, the highest Q1 on record. and a CDC study in emerging infectious diseases in May 2025 used an ensemble forecast model to project over 12,000 California cases for the April 2024 through March 2025 period, 62% higher than 2 years prior. That study explicitly linked the surge to drought terrain hydroclimatic whiplash. The fungus grows during wet years. Then the soil dries, cracks, and the spores go airborne. So hold that mechanism. Wet grows the fungus. Dry frees the spores. And the Southwest has just come through a significant El Niño winter, followed by the hottest, driest spring ever recorded. And if you think this is a problem confined to 2 states, hold that thought. Morgan Goris at Los Alamos National Laboratory published a study in GeoHealth in 2019, modeling the climate-limited range of Coccidioides. The fungus thrives where mean annual temperature exceeds 51 degrees Fahrenheit, and annual precipitation stays below 24 inches. Under high warming scenarios, Goris projects the endemic area more than doubling by the end of the century. Affected states rise from 12 to 17. Cases increase 50%, and the zone pushes north into Idaho, Wyoming, Montana, Nebraska, and the Dakotas. Goris's words, "We are watching the valley fever endemic area expanding from the southwestern U.S. all the way up to the Canadian border by the end of the 21st century." UCLA's Sean Young put it more bluntly, "Valley fever is an urgent health crisis because of climate change." That expansion is not a 2080 problem. It is already in motion. Physicians in states that have never historically seen valley fever are beginning to encounter it, and those physicians, in most cases, have no training in recognizing it. Now, I have to be honest with you here, because the honest answer is the one that makes this investigation more compelling, not less. The question of whether a single dust storm, one Haboob, directly triggers a spike in valley fever cases afterward is genuinely contested in the peer-reviewed literature. It is not settled. Andrew Comrie at the University of Arizona analyzed roughly 100 dust storms across Maricopa and Kern counties from 2006 through 2020 and found no consistent correlation between individual storm events and subsequent case clusters. A 2015 Arizona study actually found higher airborne Coccidioides concentrations in the air before a storm than during one, suggesting the spores might already be aloft when the wall arrives. That does not mean dust and valley fever are unconnected. The decadal scale correlation, Tong's finding that dust storm frequency rose 240%, while valley fever incidence rose over 800%, is striking and repeatedly cited. But correlation across decades and causation from a single event are different scientific claims, and the literature has not closed that gap. Researchers are still arguing about exactly how far the spores travel, whether the outflow boundary of a Haboob is the primary dispersal mechanism, or whether subtler ambient winds do more of the work, and whether the real risk from a storm is the dust itself or the soil disturbance it leaves behind for subsequent winds to exploit. I am going to carry that uncertainty through the rest of this investigation. I will not pretend it is resolved, but I am going to walk you through the one historical event where the connection between a single catastrophic storm and a documented valley fever outbreak comes as close to proven as this science gets, an event that moved enough soil to bury a small town and seeded infections hundreds of miles from the source. That event hit Kern County, California on December 20th, 1977. And it changes the way you think about what a dust storm can do. Part 6, The Tempest from Tehachapi. And this is where the story takes a turn that most dust storm coverage completely misses. Because what happened in Kern County, California on December 20th, 1977 was not just a dust storm. It was a natural experiment, the kind that no ethics board would ever approve, run involuntarily on an entire region, with results that showed up in hospitals weeks later. I want to walk you through it as a scene because the scale of this event is hard to absorb in summary. The Santa Ana winds that morning were not typical. They were hurricane strength. The anemometer at the Arvin weather station recorded 88 miles per hour before the instrument broke, not before the wind peaked, before the instrument physically failed. so the actual maximum was higher than 88, and we will never know by how much. The winds screamed through the Tehachapi Pass, a natural funnel connecting the Mojave Desert to the San Joaquin Valley, and accelerated as they descended into the southern valley floor. Kern County, at that time, was one of the most productive agricultural regions in California, and much of that land had been tilled, planted, harvested, and left with its surface exposed heading into winter. What happened next was less a storm and more an excavation. In a single day, approximately 25 million tons of topsoil moved. I want you to hold that figure for a moment. 25 million tons, not over a growing season, not over a drought year, in one event across one county in one afternoon. The soil was scoured to a depth of 15 centimeters, about 6 inches stripped off the surface of the earth, as if someone had taken a belt sander to the entire valley floor. Visibility dropped to near zero across hundreds of square miles. Cars were sandblasted down to bare metal. Power lines came down. Orchards were stripped. Roads became impassable, not from debris, but from drifts of soil piled across the asphalt like snow. Irrigation canals filled with sediment. The agricultural infrastructure of one of California's most productive counties was, for a period of days, functionally destroyed. 5 people were confirmed dead, though some historical sources report 9. The discrepancy has never been fully resolved in the literature, and I want to flag that, rather than pretend one number is definitive. 70% of homes in Arvin, Edison, and East Bakersfield sustained structural damage from the wind and the abrasive force of the airborne soil hits grinding against walls, windows, and roof lines for hours. Total damage ran between $34 and $40 million in 1977 dollars, which adjusts to well over $150 million today. The National Weather Service ranks it 9th among California's top 20 weather events of the entire 20th century, and the dust did not stay in Kern County. It traveled. Surface reports and subsequent analysis tracked the plume north into central California, into the Sacramento Valley, and as far as southern Oregon. The atmosphere carried 25 million tons of Kern County topsoil across state lines. Now here is the pivot. The reason this event sits at the center of a scientific argument that has not been settled in nearly 50 years. Within weeks of the storm, physicians in Kern County began seeing a spike in valley fever cases, not a gradual uptick, a pulse. Papagiannis and Einstein documented the outbreak in 1978. Flynn and colleagues followed up in 79. The case cluster was statistically distinct, temporally aligned with the storm, and geographically correlated with the dust plume's trajectory. Cases appeared not just in Kern County, but as far north as communities in the Sacramento Valley that had never been considered part of the Coccidioides endemic zone. People who had no reason to expect valley fever, who had never lived in desert soil territory, were showing up in clinics with fevers and chest infiltrates and positive cocci serologies. This is the single strongest piece of evidence in the entire scientific literature connecting a specific dust event to a specific valley fever outbreak. And the reason it is so persuasive, the reason researchers still cite it nearly 5 decades later as the canonical case, is the mechanism. The wind did not just pick up surface dust, the way a monsoon outflow does. It scoured, 15 centimeters deep. It excavated the exact soil horizon where Coccidioides lives, the upper layer where rodent burrows concentrate the organism in focal patches, where the mycelia fragment into arthroconidea and wait in a kind of suspended animation for disturbance. A typical haboob lifts what is sitting loose on the surface. The Kern County storm dug into the biological layer and launched it hundreds of miles downwind. And this distinction is not something I am inventing. It is the core of the scientific disagreement. Comrie's 2021 analysis, published in GeoHealth, a rigorous journal, looked at conventional haboobs, the outflow-driven dust storms that are intense but measured in minutes, events where the wall rolls through and the air clears within an hour. And across roughly 100 of those events in Maricopa and Kern counties from 2006 to 2020, he found no consistent valley fever signal in the weeks that followed. That is a significant finding. It means that the standard monsoon haboob, The kind Phoenix sees a dozen or more times every summer probably does not, by itself, produce a measurable case spike. At least not one that current surveillance can detect. But the Kern County event was a fundamentally different category of disturbance. Sustained, multi-hour, hurricane-force wind, physically removing inches of topsoil across a vast agricultural basin. The difference is like comparing a broom sweeping a floor to a jackhammer cracking it open. Both involve the floor. Only one exposes what is underneath. So the question, and I want to be precise about how to frame this because the precision matters, is not, do dust storms cause valley fever? That question is too blunt for the science. The real question is, what type of soil disturbance, at what depth, over what area, at what wind speed and duration produces a fungal exposure event that current surveillance can detect? And the answer, based on the best available evidence, is that the threshold is higher than a typical 10-minute Haboob, but potentially lower than people assume, because the 1977 Kern event was extreme, but it was not geologically unusual. It was a powerful Santa Ana wind hitting exposed agricultural soil. Those ingredients exist in the modern Southwest, and there is a second data point worth holding. 1994, the Northridge earthquake in Southern California. Schneider and colleagues documented in JAMA in 1997 a Coccidioides mycosis outbreak caused by landslide-generated dust in the aftermath of the quake. The earthquake shook loose hillsides in Ventura County. The hillsides became airborne dust, and the spores were inside the soil that the landslides exposed. Earthquakes and hurricane-force winds are not haboobs, but they share the critical mechanism, deep soil disturbance releasing subsurface biological material into the breathing zone. And that shared mechanism is what matters for the risk assessment I am building toward, because the question is not whether a typical Haboob can trigger an outbreak. Comry's data suggests it probably cannot. The question is what happens when conditions conspire to produce soil disturbance that exceeds the typical threshold through wildfire ground scarring, through construction at scale, through drought-exposed playas that were underwater a decade ago, and a Haboob then lofts that freshly disturbed material into a metropolitan airshed. Part 7, the poison in the playa. I have been talking about dust as if it were a single substance. It is not. And this is the part of the investigation that keeps me up at night more than the fungal biology, because the fungal biology at least has a name and a diagnostic test. What I am about to describe does not have a clean clinical category. The Salton Sea sits in the Imperial Valley of Southern California, roughly 150 miles southeast of Los Angeles. It was created accidentally in 1905 when an irrigation canal from the Colorado River broke and the river poured into the Salton Sink, a below sea level basin in the desert, for nearly 2 years before engineers could stop it. For decades, the resulting lake was a resort destination, a bizarre and oddly beautiful desert sea surrounded by date palms and mid-century motels, stocked with fish, visited by hundreds of species of migratory birds on the Pacific Flyway. It was, for a while, the most popular state park in California. But the Salton Sea has no natural outlet. Every gallon that enters either evaporates or stays, and as agricultural inflows have declined, diverted to serve growing cities, reduced by the same drought draining Lake Mead, the sea has been shrinking for decades. Salinity has climbed past ocean levels. The fish died, the birds moved on, the resorts crumbled, and as the water recedes, it exposes lakebed. Between 16,000 and 20,000 acres of playa are now exposed, with more emerging every year as the shoreline contracts. That lakebed is not clean sand. It is not even ordinary desert sediment. It is a chemical repository, a sink where decades of agricultural runoff from one of the most intensively farmed regions in the country accumulated and concentrated through evaporation. USGS sediment sampling at 73 locations found the runoff was loaded with salts, pesticides, selenium, and other metals, the residue of industrial-scale agriculture that used the Salton Sea as its drain. The exposed playa now contains arsenic, lead, chromium, selenium, cadmium, and organohalogen and organophosphate pesticide residues that researchers at San Diego State University and the Scripps Institution of Oceanography are currently characterizing using gas chromatography mass spectrometry and inductively coupled plasma mass spectrometry. The analysis is funded by the California Air Resources Board. The results are not yet complete. I want to be clear about that. Amato Evan at UC San Diego's UC Dust program has stated that the region's agricultural history makes toxic dust composition probable, but that the specific chemical fingerprint still needs comprehensive study. Some claims about Salton Sea dust toxicity are ahead of the published data. I'm not going to pretend otherwise, but the health signal is already arriving, and it is not subtle. Jill Johnston at USC published in Environmental Research a study finding that 24% of children living near the exposed Salton Sea playa have asthma. The national average is 8.4% for boys and 5.5% for girls. So children in this community are developing asthma at roughly 3 to 4 times the national rate. And these are not children with unusual genetic susceptibility or unusual indoor exposures. They are children breathing the air that the playa sends them. A UC Irvine spirometry study conducted from 2019 through 2022 in partnership with Comité Civico del Valle, a local environmental justice organization, and funded by the National Institute of Environmental Health Sciences, measured lung function in approximately 500 children near the age of 10. The researchers did not just find elevated asthma rates. They found measurably reduced lung function linked to windblown Salton sea dust exposure. These children's lungs are not developing to their full capacity. The damage is being built into their bodies, while the chemical characterization of what is causing it is still being finalized in laboratories. That sequence, health harm, arriving before the science is complete, communities bearing the burden while researchers publish, should sound familiar to anyone who followed the Flint water story, or Camp Lejeune, or the burn pit litigation. The pattern is distressingly consistent. The harm is fast. The proof is slow. The people in the path cannot wait for the proof. About 100,000 people live within 10 miles of the receding shoreline. Many of them are farm worker families. The University of Arizona's 2024 Farm Worker Enumeration Profile Study, the first credible count since 2008, is still establishing how many agricultural laborers work in the region's fields. But older estimates placed Arizona's farm labor force near 100,000, and Imperial Valley is one of the most labor-intensive agricultural zones in the country. These are workers who spend 8, 10, 12 hours a day outdoors, breathing whatever the wind carries. The Imperial Valley routinely receives failing grades from the American Lung Association for both particulate and ozone pollution, and the air quality picture across the broader region is deteriorating. The ALA's State of the Air 2026 report, released April 22, 2026, ranked the Phoenix Metro 4th worst in the nation for ozone and 15th worst for year-round PM 2.5, worsened from 20th the prior year. El Paso surged in the IQ Air 2025 rankings after spring dust storms. The March 3rd through 6th, 2025 storms produced 4 of the 5 most polluted days ever recorded at the Chamizal Monitor, which has been operating since 1999. David Lowe at UC Riverside has conducted laboratory studies showing that Salton sea dust has unique chemical and physical characteristics that drive health impacts distinct from generic desert dust. This is not ordinary sand. It is agricultural chemistry aerosolized and delivered to the lungs of the nearest community, which happens to be overwhelmingly Latino, overwhelmingly low income, and overwhelmingly invisible in national media coverage. And here is the compound connection I need you to hold alongside the valley fever data. A haboob does not discriminate between fungal soil and toxic playa. When outflow winds cross the Sonoran and Mojave deserts, they loft whatever the surface holds. In some corridors, that is Coccidioides spores. In others, that is arsenic and pesticide residue. In some, particularly the basins fed by reduced Colorado River flows, the same flows draining the reservoirs I opened this investigation with, it is both. The USGS conducted a basin fill aquifer study, Survey Information Map 3234 RAS, modeling arsenic distribution across roughly 190,600 square miles of Arizona, California, Colorado, Nevada, New Mexico, and Utah. Elevated arsenic in the soil-sea horizon appears across broad swaths of the southern high plains and the desert southwest. This is not a local problem. The chemistry is regional. The wind does not respect county lines. A Part 8, the dust that killed 7,000. I want to zoom out now, because this investigation would be incomplete without the historical event that proved, beyond any reasonable argument, what happens when you combine exposed soil, sustained wind, and an unprepared population. And I am bringing it in not as background history, but as direct evidence, because every variable that created the Dust Bowl is operationally active in modified form across the Southwest right now. The 1930s, the southern Great Plains, decades of aggressive cultivation had stripped the native grassland from millions of acres of prairie, sod that had held the soil in place through thousands of years of drought cycles, ripped up in a generation by the steel plow and the promise of wheat prices. When the rains failed, and they failed for years, the soil had nothing holding it down. No root structure, no ground cover, just loose, plowed earth stretching to the horizon in every direction, waiting for wind. The dust storms began. In 1937 alone, 72 storms reduced visibility below 1 mile across the southern plains. The most famous, Black Sunday, April 14th, 1935, is seared into American memory for a reason. Eyewitnesses in the Texas and Oklahoma panhandles described a wall of black dust rolling in from the north that turned afternoon into absolute darkness in minutes. People could not see their hands in front of their faces. Livestock suffocated in the fields. Children caught outside were found by rescue parties only after the storm passed, huddled against fences, their mouths and nostrils packed with dirt. Somewhere between 3 and 4 inches of topsoil were lost across the worst hit regions. Soil that had taken centuries to build, gone in a season. Wheat production fell 36%. Maize fell 48%. 2.5 million people left. They packed what they could carry and drove west on roads lined with others doing the same, and approximately 7,000 people died of what physicians at the time called dust pneumonia. The pathology was exactly what the name suggests: lungs overwhelmed by sustained exposure to fine particulate, inflamed beyond recovery, filling with fluid the body could not clear because every breath brought in more of the material causing the damage. Texas Tech researchers, Nugent and colleagues, published in the American Journal of Medical Sciences in 2018, went back through the Kansas mortality records with modern epidemiological methods and documented not just the respiratory deaths, but increases in measles hospitalizations, infant mortality, and overall mortality in communities during the worst storm years. And they noted something that maps directly onto the modern JUNG data from JAMA Network Open. Dust-related mortality rises with a 2 to 3 day lag. The exposure is immediate. The dying takes days. The hospital does not see the surge until the damage is already seeded in the tissue. 7,000 dead from breathing dirt in the richest country on earth in the space of a few years. And the primary driver was not a climate anomaly, though drought was the trigger. The primary driver was land management, overcultivation, the systematic removal of the biological systems, the deep-rooted grasses, the mycorrhizal networks, the biological soil crust that had held the soil in place through every previous drought. The Dust Bowl was, at its root, a human-caused dust catastrophe with a climate accelerant. The atmosphere provided the drought. Human decisions provided the vulnerability. And that framing matters enormously for what is happening right now. The modern Southwest is not the 1930s Great Plains. The crops are different. The soils are different. The population distribution is radically different. The Great Plains were rural. The Southwest is anchored by the 5th largest city in America. But the mechanism, human activity removing the surface integrity that keeps soil anchored, followed by climate conditions that weaponize the exposure, is identical in structure. The Salton Sea is receding because of water management decisions made decades ago that are now intersecting with a megadrought nobody planned for. The playas are exposed because the Colorado River system is overallocated and underfilled. Construction across the Sunbelt is disturbing desert surfaces at an unprecedented scale. Every new housing development, every new highway interchange, every graded lot is a patch of broken crust waiting for wind. And the megadrought is providing the sustained desiccation that makes all of it available to the next outflow boundary. 3 days ago, the video on this channel covered the fire weather corridor forming across the Intermountain West. The fuel moisture readings in that video, the dead fuel moisture levels running below critical thresholds across multiple states simultaneously, are measuring the same drought signal that is exposing the soil to dust mobilization. One hand resting on a console of levers. When that hand pushes down, when the drought deepens, when the heat intensifies, when the snowpack fails to materialize, the fire lever and the dust lever and the reservoir lever and the health lever all move together because they are connected to the same forcing mechanism. The atmosphere does not produce these hazards independently. It produces them from the same root condition. And the root condition, the megadrought, the warming, the desiccation, is not improving. It is, by every metric Williams and Smerdon measured, intensifying. That is the compound connection at the heart of this entire investigation. Not that dust storms are happening, and valley fever is happening, and toxic playa is happening, and wildfires are happening. That is just a list. The connection is that they are all expressions of the same underlying shift, amplified by the same forcing, converging on the same population, and that the institutions tasked with managing them are structured as if they were separate problems. Part 9. The afternoon, everything hits at once. So far, I have walked you through the dust, the biology, the chemistry, and the history as separate threads. Separate investigations, almost, each one with its own evidence base, its own named researchers, its own institutional knowledge. This part is where the threads braid together. And the braid is the actual threat, because no single element of what I have described, taken alone, would overwhelm the emergency management systems in place across the Southwest. Phoenix survives Haboobs every summer. Arizona's hospitals manage asthma surges. The Highway Patrol responds to pileups. The health department tracks valley fever. Each system handles its individual hazard within acceptable parameters most of the time. It is the combination that breaks them. And the combination is what the data says is coming. Picture this. It is mid-July 2026. The monsoon is active, the Climate Prediction Center's favored scenario, supported by the El Niño persistence forecast at greater than 95% confidence. A cluster of thunderstorms builds over the desert south of Phoenix in the mid-afternoon, fed by moisture surging north from the Gulf of California. They mature rapidly in the unstable air. They collapse. The outflow boundary races north across the open basins, the same basins that the megadrought has been desiccating for 26 consecutive years, the same surfaces where biological soil crust has been destroyed by off-road vehicles and construction grading, the same soils that may harbor Coccidioides and focal patches. No one has mapped because no comprehensive survey of fungal distribution exists for the Phoenix metropolitan airshed. The wall builds 5,000 feet, 100 miles wide, advancing at 35 miles per hour toward a metropolitan area of 5.2 million people. And the fire season is already producing smoke. The Seven Cabins fire in New Mexico, the scattered starts across Arizona's national forests, so the baseline air quality is already degraded before the dust arrives. The leading edge hits the southern suburbs. Visibility drops to zero on I-10. The same corridor, the same mileposts, the same kill zone. Vehicles pile up. Emergency response deploys. But the storm is not just on the highway, it is on the airport. Sky Harbor, a hub that handles over 1,000 flights a day, goes into a ground stop. Last August, a single Haboob caused more than 200 delays. A stronger event could cascade into nationwide air traffic disruption. And then the power goes out. Last August, more than 60,000 customers lost electricity during a single Haboob. In mid-July, when afternoon temperatures in Phoenix routinely exceed 115 degrees Fahrenheit, losing power means losing air conditioning. And losing air conditioning in Phoenix in July is not an inconvenience. For the elderly, for children, for people with cardiovascular disease or chronic obstructive pulmonary disease. It is a life-threatening emergency layered on top of an air quality emergency. For the nearly 10,000 people experiencing homelessness in Maricopa County, per the January 2025 point-in-time count conducted by the Maricopa Association of Governments, 9,734 people, the highest figure ever recorded, roughly 53% of them unsheltered, a number driven partly by the expiration of federal funding for more than 1,000 emergency shelter beds. There is no air conditioning to lose. They are breathing the unfiltered dust in unshaded outdoor conditions at ambient temperature, and nobody is counting their exposure. The ER data tells you what happens next. Jung, Chong, Ebelt, D'Souza, Hosefield, and Crooks, a team spanning National Jewish Health, Emory, and the Colorado School of Public Health, published in JAMA Network Open in February 2025, the most comprehensive study to date on dust storm health impacts. They analyzed 33,500 emergency department visits across Arizona, California, and Utah from 2005 through 2018, covering 206 identified dust days. The findings? A 6% increase in asthma ED visits in the 2 days after a dust storm, a 6% rise in culture-negative pneumonia and congestive heart failure within a week, and a 13% increase in motor vehicle accident ED visits on the storm day itself. Arizona had the most dust-impacted zip codes in the study, 128 and the highest mean dust days per year, 16.3. A companion study by Rowan D'Souza and colleagues in environmental research, Health in 2024 found respiratory ED visits elevated 3.7% on lag day 1, 4.9% on day 2, and 5% on day 3. PM10 and PM2.5 concentrations ran 3 to 6 times higher on dust days versus non-dust days. And a separate analysis by Dimitrova and colleagues in atmospheric chemistry and physics in 2012 found a significant link between PM10 and childhood asthma hospitalizations in Central Phoenix, specifically among children ages 5 through 17. James Crooks, the senior author on the JAMA Network Open study, said something I think every emergency planner in Maricopa County needs to read. Given the expected rise in dust storms, policymakers and health officials must take proactive measures to safeguard vulnerable populations. Now add one more layer. The dust exposure in mid-July does not just cause acute respiratory distress, it starts a clock. The valley fever incubation period is 7 to 21 days. So the ER surge from the acute dust exposure, the asthma attacks, the car crashes, the heat casualties from power failure, that is the first wave. The second wave arrives 2 to 3 weeks later, when the people who inhaled Coccidioides spores during the storm begin developing fever, cough, and the crushing fatigue that sends them back to the same emergency departments that are still clearing the backlog from the first wave. And the system those two waves hit is not built with margin. Banner Health, headquartered in Phoenix, Arizona's largest health system, and the state's largest private employer with approximately 60,000 employees, operates 33 hospitals across 6 states. Banner University Medical Center Phoenix has roughly 712 to 755 beds as a Level 1 trauma center. BUMC Tucson runs 649 beds. Valleywise Health Medical Center, the only nationally verified burn center in Arizona, has 555 beds. Across the entire state, Arizona had approximately 13,296 staffed beds in 145 hospitals, with 66 of those hospitals in the Phoenix metro. County-specific ICU capacity and current occupancy rates are, as of this investigation, an unconfirmed data gap. I looked. I could not find publicly available real-time ICU census data for Maricopa County. That itself is information, because in a compound event, knowing how much surge capacity exists before the surge begins is the single most important variable in the emergency management equation, and that number does not appear to be publicly tracked or reported in a way that community members or even researchers can access. Arizona's adult asthma prevalence stands at 9.8% per the 2022 Behavioral Risk Factor Surveillance System and the Arizona Department of Health Services June 2025 Asthma Burden Report. Applied to the Metro Phoenix population, that implies roughly 550,000 to 600,000 adults with pre-existing airway vulnerability living in the footprint of a single Haboob. This is an extrapolation. The ADHS report contains more precise figures, but the order of magnitude is clear. 500,000 people with compromised airways sitting under conditions primed to deliver the worst air quality event a modern American city has faced. Every element of the scenario I just described has a documented precedent in the data assembled in this investigation. The dust height, the wind speed, the particle loading, the power outages, the highway pileups, the ER surges, the valley fever incubation lag, the hospital bed constraints, the unsheltered population, the wildfire smoke overlay. None of it is speculative. All of it has happened, just never all at once, to this population at this scale. And that never all at once is the whole question this investigation is circling, because the planning documents, the surge capacity models, the mutual aid agreements between Arizona counties, they were built against individual hazards arriving one at a time, spaced out enough for recovery between events. A dust storm, and then a heat wave, and then a flu season. Not a dust storm, during a heat wave, during fire season, during a pandemic-era staffing shortage with valley fever cases already at record levels before the monsoon begins. The atmosphere does not read planning documents. It does not schedule its emergencies sequentially to avoid overwhelming the system. And I want to be careful here. I am not predicting this scenario for this summer. I am not forecasting a mass casualty compound event in Phoenix in July 2026. Prediction is not what this investigation does. What this investigation does is show you what the preconditions look like, show you what the historical precedents demonstrate, and ask whether the systems in place are calibrated against the event that the data says is physically possible. The answer, based on everything I have assembled, is that they are not. And the gap between what is possible and what is planned for, that gap is not closing. It is widening. Every year the drought persists. Every year the dust frequency increases. Every year valley fever sets a new record. That gap gets wider. The next section of this investigation deals with something that has been building in the comment sections and across social media for as long as dust storms have been filmed from dash cams and posted online. The conspiracy explanation. And I want to address it head on because the people asking deserve an actual answer, and because the real version of what they are worried about is more documented, more provable, and more alarming than the version they have been sold. Part 10, the conspiracy and the contrail. I want to address this directly, and I want to start by naming the specific claim, not gesturing at it vaguely. Naming it. The claim is that governments, usually the United States government, sometimes a vaguer they, are deliberately spraying chemical or biological agents from aircraft at high altitude, and that the persistent white trails visible behind jet aircraft are evidence of this program. The theory is usually called chemtrails. In its updated form, it is framed as covert geoengineering, weather modification conducted without public consent. The origin, as best as researchers have traced it, was a 1996 United States Air Force research paper on hypothetical weather modification capabilities, which was a speculative think tank exercise about future military technology. It was not a program description. It was not an operational plan. It was essentially a what-if paper, the kind that military institutions produce by the hundreds every year about every conceivable topic. But it was read and circulated as a confession, and the theory has grown from there for 3 decades. Tucker Carlson's 2025 interview with Dane Wigington of Geoengineering Watch drove a significant spike in public attention. Wigington has been the most visible proponent of the geoengineering version of the theory for over a decade. Lawmakers in more than 30 states have now introduced anti-geoengineering bills in response to constituent pressure, bills that range from symbolic resolutions to proposed criminal penalties for atmospheric spraying. The belief is widespread, it is growing, and it is not confined to any single political demographic. And the impulse behind it is understandable. I want to say that clearly before I say anything else, because dismissing the impulse would be dishonest and it would also be ineffective. When extreme weather events are increasing in frequency and severity, and they verifiably are by every metric in this investigation, and when official explanations feel insufficient or evasive, and sometimes they genuinely are, as I have documented in the classification gaps and the surveillance lags, people look for explanations that match the scale of what they are experiencing. The atmosphere is complicated, does not feel adequate when you are watching your neighborhood flood for the third time in a decade, or when a wall of dust swallows your city and your child starts coughing, or when a disease you have never heard of shows up in your lungs. The desire for a coherent, human-scale explanation is rational. The specific explanation the chemtrail theory offers is wrong, but the frustration that fuels it is legitimate. Here is why. Persistent contrails, the white lines behind aircraft, are ice crystals. When jet fuel combusts at high altitude, the exhaust contains water vapor along with carbon dioxide and other combustion products. In cold, humid air at cruise altitude, typically above 30,000 feet, where temperatures routinely drop below -40 degrees, that water vapor nucleates into ice crystals that can persist for minutes or hours depending on atmospheric humidity at that level. If the surrounding air is dry, the contrail dissipates quickly. If the surrounding air is humid and near saturation, the contrail spreads and can persist for hours, sometimes expanding into cirrus-like cloud cover. This has been understood, documented, photographed, and studied since the 1940s. Allied bomber formations left contrails over Europe in World War II that were visible from the ground and used by German anti-aircraft batteries as targeting references. The EPA, FAA, NASA, and NOAA jointly published a fact sheet in the year 2000 confirming the physics and addressing the emerging chemtrail claims directly. Contrails are not new. Persistent contrails are not new, and the variation in their persistence, some lasting seconds, some lasting hours, is a function of humidity at cruise altitude, not a function of whether one aircraft is spraying chemicals and another is not. But here is the thing. The contrail chemistry, while settled science, is actually the weakest argument against the chemtrail theory for this specific episode. The physics argument that kills it is simpler, more direct, and more devastating. Haboobs are ground-level phenomena. They form at the surface and rise to between 1,000 and 6,000 feet. The tallest documented events reaching roughly 1 mile. Commercial aircraft cruise at 30 to 40,000 feet. The two phenomena are separated by 5 to 7 miles of vertical atmosphere. There is no physical mechanism, none, by which material released at cruise altitude generates a surface-level outflow-driven dust storm. The outflow is produced by the collapse of a thunderstorm cell. The dust is mobilized by that outflow, racing across dry ground. Both processes are entirely independent of what is happening at 40,000 feet. Whatever is occurring at cruise altitude, contrails, ice crystal formation, solar reflection, anything, it has no energetic or mechanical pathway to the surface outflow that creates a haboob. The altitudes do not connect. The processes do not connect. The physics do not connect. And on the energy question specifically, because this is where the weather modification framing of the theory collapses most completely, consider the numbers. HAARP, the High Frequency Active Auroral Research Program in Gacona, Alaska, is the facility most commonly cited as the supposed engine of alleged weather control. It is a real facility, an ionospheric research station operated now by the University of Alaska Fairbanks, previously funded by DARPA and the military. It is not secret. You can visit it. Its maximum radio frequency output is 3.6 megawatts. A single monsoon thunderstorm of the type that generates haboobs releases energy equivalent to roughly 10 to 100 times the output of a nuclear power plant, sustained over hours. The entire monsoon season across the Southwest involves thousands of such storms. A hurricane, which the theory sometimes claims is also steered or created by similar technology, releases energy equivalent to approximately half the total electrical consumption of the United States in a year, 3.6 megawatts versus the energy output of an industrialized nation. That is not a difference of degree. That is not a difference that better engineering could close. That is 12 orders of magnitude, a factor of 1 trillion. That is the difference between a flashlight and the sun. You cannot steer a hurricane with a flashlight. You cannot generate a ground-level dust storm from a radio antenna with the output power of a small FM transmitter. The energy is not there. The physics does not work. And dressing the claim in technical-sounding language about ionospheric heating and frequency resonance does not change the arithmetic. The theory is wrong. I am saying that plainly because I think the people who hold it deserve a plain answer rather than a dismissive one. The persistent contrails are ice. The dust storms are surface outflow, and no credible physics connects one to the other. Part 11, The Honest Steelman, but here is where the conversation gets genuinely interesting, because there is a truthful version of the claim humans are putting harmful material in the air you breathe. It is just not the version the conspiracy framing presents. Cloud seeding is real. It has been practiced for decades. Silver iodide particles are released into clouds, usually from ground-based generators or small aircraft, flying within the cloud to serve as ice nuclei that encourage precipitation. It is used by agricultural interests and water managers across the western United States to squeeze additional snowpack out of winter storms. It is regulated, it is documented, it is openly discussed in water management literature, and it has absolutely nothing to do with generating dust storms. Silver iodide encourages rain. Dust storms form when there is no rain and the soil is dry. The two are mechanistically opposite. I am naming cloud seeding explicitly so that it does not get confused with the chemtrail claim, a confusion that happens constantly in comment sections and that muddies both conversations. Now, the real anthropogenic dust story. And this is the part I have been building toward since part 7, because it is the part that takes the legitimate frustration behind the conspiracy and connects it to documented, measurable, actionable reality. Humans are, in documented, dated, and measurable ways, increasing the amount of harmful particulate matter in the air of the American Southwest. But the mechanism is land use and water management, not secret spraying. And the evidence is not hidden. It is published, it is peer-reviewed, it is sitting on government servers. Anyone with an internet connection can read it. Start with the Salton Sea playa I described earlier. That toxic lakebed exists because of a chain of water management decisions stretching back over a century. The original canal breach in 1905, the subsequent agricultural drainage that treated the sea as a dump, and the Colorado River allocations that have steadily reduced inflow as the climate has dried and cities have grown. The arsenic, the pesticides, the chromium, that chemistry is there because of industrial agriculture and its relationship to a closed basin lake with no outlet. When wind picks up that sediment, it is delivering human-caused contamination to human lungs. That is not theory. USGS documented the sediment chemistry. CARB funded the atmospheric analysis. USC measured the childhood asthma rates. UC Irvine measured the lung function deficits. The evidence chain is complete, and the Salton Sea is not even the most dramatic precedent within California's own borders. Owens Lake, in eastern California's Inyo County, drained beginning in 1913 by the Los Angeles Aqueduct, the same water diversion that inspired the film Chinatown, became the single largest source of PM10 pollution in the United States after the water was removed. By the 1990s, the dry lakebed was generating dust storms visible from space, with particulate concentrations that exceeded EPA standards by factors of 10 or more. The Great Basin Unified Air Pollution Control District fought the city of Los Angeles for decades, eventually forcing the city to spend hundreds of millions of dollars on dust mitigation, shallow flooding, gravel blankets, managed saltgrass plantings, to suppress the particulate from a lake that Los Angeles drained to fill its swimming pools, water its lawns, and build a metropolis in a semi-arid basin 100 years ago. Today, the mitigation costs exceed $1 billion, and the work is still ongoing. That is not a conspiracy. That is a municipal water policy decision made in 1913, documented in court records stretching across a century, measured by EPA monitors, and paid for by ratepayers who were not alive when the decision was made. If you want to understand how human decisions create dust emergencies, Owens Lake is the textbook. The Dust Bowl killed 7,000 people because of overcultivation. Millions of acres of native grassland ripped up by human decisions, leaving soil exposed to drought winds that the grass had been holding in place for millennia. That was the largest human-caused dust catastrophe in American history, and its root cause was agricultural policy, not atmospheric chemistry. Construction across the Sun Belt is breaking the desert's biological soil crust, the thin, living layer of cyanobacteria, lichens, and mosses that holds desert soil in place against wind, at a pace that has no precedent in the region's history. Every new subdivision graded outside Phoenix, every highway interchange widened outside Tucson, every warehouse pad leveled in the Inland Empire, every solar farm cleared outside Las Vegas creates a patch of newly exposed, newly loftable soil. That biological crust can take decades to regenerate. The grading takes an afternoon, and the megadrought itself, as Williams established at 42% attributable to human-caused warming, is desiccating the landscape in a way that makes all existing dust sources more productive. Playas that held moisture 10 years ago are dry. River channels that flowed seasonally are cracked. Agricultural fields that were irrigated are being fallowed as water allocations are cut. So the truthful version of humans are putting harmful material in the air is this: human land use decisions over the past century, over-cultivation of marginal soils, over-allocation of water resources in a drying climate, urban sprawl into desert terrain that breaks the surface holding the dust down, and fossil fuel emissions driving the megadrought that makes all of it worse have systematically increased the quantity, toxicity, and biological payload of dust available to be lofted by natural wind events. The Salton Sea is not an accident of nature, it is a consequence of irrigation engineering. The Owens Lake dust was not a natural hazard, it was a consequence of municipal water theft. The Dust Bowl was not an act of God, it was an act of the plow. And the current megadrought carries a 42% human fingerprint that connects every modern dust event, at least partially, to decisions made about energy and emissions over the past century and a half. The mechanism is documented. The evidence is peer-reviewed. The health consequences are being measured in real time in the lung function of children living near the Salton Sea, in the valley fever wards of Arizona hospitals, and in the mortality databases that Daniel Tong had to cross-reference because the official count was filing dust deaths in the wrong category. That is the real story. That is the actual human fingerprint on the dust crisis unfolding across the American Southwest. Not trails behind aircraft at 40,000 feet. Decisions on the ground, accumulated over decades, now intersecting with a climate system that is amplifying their consequences faster than institutions can adapt. And I think there is something important, something the investigation needs to sit with for a moment, in the fact that the true explanation is, in meaningful ways, more unsettling than the conspiracy. A covert spraying program could, in theory, be stopped. Expose it, legislate against it, hold the perpetrators accountable. The actual drivers, entrenched land use patterns codified in property law, and agricultural subsidies. Water rights built on 19th century assumptions of river flow that no longer apply, warming already locked into the climate system by decades of cumulative emissions. Urban development patterns driven by population growth and economic incentive, these cannot be stopped by a congressional hearing or a viral documentary. They require structural change at a scale that no single election, no single agency, no single policy instrument can deliver overnight. The real answer is harder than the conspiracy. It demands more of us, and it offers no villain simple enough to fit on a protest sign. Part 12. What the monsoon means this summer. I want to bring this back to June 2026 because everything I have shown you, the physics, the biology, the chemistry, the history, the human fingerprint, converges on a very specific window that is opening right now. Not next year, not in a decade, in weeks. The Climate Prediction Center's current outlook calls for El Niño to persist through fall and winter with greater than 95% confidence. That is an extraordinary level of model agreement. The ensemble runs are nearly unanimous. The North American monsoon, the seasonal thunderstorm pattern that delivers the majority of annual precipitation to the desert Southwest from roughly July through September, is expected near to above normal. For water supply, that is cautiously encouraging. For dust, it is not. Here is why, and I need to walk through this carefully, because the relationship between monsoon strength and dust risk is counterintuitive enough that most weather coverage gets it exactly backward. A stronger monsoon means more thunderstorms. More thunderstorms mean more collapses. More collapses mean more outflow boundaries. And those outflow boundaries are going to hit a surface that is, by every measurement I have presented in this investigation, the driest, most exposed, most dust productive it has been in over a millennium. The Arizona NWS offices that cover this region, NWS Phoenix in Tempe, NWS Tucson, and NWS El Paso, which covers the Lordsburg Playa corridor into New Mexico, are going to be issuing dust storm warnings through a monsoon season that has more energy available to mobilize more material from more exposed ground than any they have experienced in the modern record. You can track this yourself. The SPC Day 1 convective outlooks, the NWS area forecast discussions from the Phoenix and Tucson offices, the dust storm warnings and blowing dust advisories that appear in the hazardous weather alerts feed. The operational products are public, and watching them through July and August of this year, against the background I have laid out in this investigation, will give you a real-time view of the outflows hitting the surface I have described. More monsoon does not mean less dust. It means more powerful engines of dust mobilization striking a surface primed to supply them. That is the paradox nobody is putting on a weather graphic. And then the wet-dry whiplash enters the picture, a dynamic that the CDC study I cited earlier, published in Emerging Infectious Diseases in May 2025, explicitly flagged as the driver of California's record valley fever surge. The mechanism for Coccidioides amplification works on a seasonal rhythm that the fungus has evolved over millennia. Wet periods, El Niño winters, above normal monsoon rainfall stimulate fungal growth in the soil. The mycelia extend through the soil matrix, colonize new territory around rodent burrows and organic debris, and produce more arthroconidia. The fungus is banking spores. Then the dry period arrives. The soil desiccates. The mycelia fragment. The arthroconidia sit in the cracked soil like seeds in a dry pod, waiting for mechanical disturbance to launch them into the air column. The Southwest has just completed an El Niño winter that delivered above normal precipitation to parts of the region, followed immediately by the hottest, driest spring on record for the major metro areas. That is the whiplash sequence operating at textbook speed. The fungus grew during the wet months, December through March, in the soils of the basins and valleys across Arizona and California's Central Valley. The soil then baked and cracked through April, May, and June under record temperatures. The arthroconidia are sitting in those cracks now, in the focal patches near rodent burrows, in the construction zones where grading exposed subsurface soil, in the fire scars where the biological crust has been destroyed, and the monsoon outflows of July through September are about to provide the dispersal mechanism. The clinical burden this lands on is not starting from zero. John Galgiani and Fariba Donovan at the University of Arizona Valley Fever Center for Excellence have spent years documenting the diagnostic delays and treatment challenges that define this disease. The average patient bounces through multiple physician visits before getting a correct diagnosis. The cost, in both dollars and suffering, is enormous. $23,000 for an uncomplicated case, over $1 million for disseminated disease, and an incalculable toll in months of misdiagnosis, inappropriate antibiotic courses, lost work, and chronic fatigue that can persist for years after the acute infection resolves. I am not predicting a record valley fever year for Arizona or California in 2026. Spring forecasts of infectious disease are notoriously uncertain. 2014 is the cautionary tale that every valley fever researcher knows, when confident predictions of a major outbreak were followed by a relatively quiet season that humbled the models. A careful person holds that fact in the other hand. But the preconditions, the drought baseline, the record heat, the El Niño-fed fungal growth cycle, the exposed soil, the strong monsoon forecast, align more completely in 2026 than in any recent year I can identify in the published record. And the burden of Arizona's 14,700 plus cases in 2024 and California's 12,600 plus was already straining the diagnostic and treatment infrastructure before the 2026 monsoon has even begun. And the surveillance system that would detect a surge has known structural lag times that I need you to understand, because they matter for how you interpret the data you will see later this summer. Arizona reports valley fever cases weekly through the ADHS system, with Thomas Williamson serving as the state's mycotic epidemiologist tracking the data. But the incubation period is 7 to 21 days. Diagnostic testing, serology, culture, antigen detection adds additional time. And the disease is reportable in only 28 states plus the District of Columbia, meaning cases that occur in people who traveled through the Southwest and returned home to, say, Ohio or Michigan, may never appear in the Arizona or California counts at all. If a major dust event seeds a widespread Coccidioides exposure across Metro Phoenix in mid-July, the earliest confirmed cases would not appear in the surveillance data until mid-August at best. A surge large enough to strain hospital capacity would not be visible in the weekly epidemiological reports until weeks after the emergency departments are already feeling the pressure. The system sees the signal after the damage is seeded in tissue. That is not a flaw in the people running the system. Williamson's team at ADHS does rigorous work under real constraints. It is a structural feature of how infectious disease surveillance works when the pathogen is delivered by the atmosphere to an entire metropolitan area simultaneously, rather than spreading person to person through contact chains that can be traced and interrupted. And this is where the classification gap from Part 3 returns with its full weight. The dust deaths filed under high winds. The valley fever cases tracked by the health department on a separate system. The highway fatalities tracked by ADOT and the Federal Fatality Analysis Reporting System. The power outages tracked by Arizona Public Service and Salt River Project. The ER surges tracked by hospital networks. The flight delays tracked by the FAA. Nobody, no single agency, no unified dashboard, no joint operations center is integrating all of these as expressions of the same atmospheric event. A dust storm that kills people on I-10, sends hundreds to emergency rooms, knocks out power to tens of thousands of homes in lethal heat, seeds thousands of people with fungal exposure, and shuts down the 11th busiest airport in the country, generates entries in at least 6 separate institutional databases maintained by at least 6 separate agencies. And in none of those databases does the event appear as what it actually was, a single compound emergency driven by a single outflow boundary crossing a single drought-ravaged landscape. Part 13, the pattern you can see from orbit. I want to zoom out one more time because there is a dimension of this story that only becomes visible at planetary scale, and it changes how you think about whether the American Southwest's dust crisis is anomalous or whether it is early. The Sahel, the semi-arid band stretching across Africa south of the Sahara from Senegal to Sudan, has been living the intersection of drought, dust, and respiratory disease for decades. It is the region where the word Haboob was born. Meningitis outbreaks in the Sahel correlate with dust season. The dry Harmattan winds carry particulate matter that damages respiratory mucosa and opens pathways for bacterial infection. Khartoum, where the AMS definition of Haboob originates, averages 24 major dust storms a year. The health infrastructure serving those populations, clinics with intermittent electricity, hospitals hours from the nearest referral center, is a fraction of what exists in Maricopa County. And the Sahel's experience is not just a humanitarian concern at a distance, it is a preview. It is what intensifying aridity delivers to every population in its path, regardless of GDP per capita. Escalating dust loads, escalating respiratory burden, escalating pressure on systems that were designed for a different climate regime. Central Asia offers the other instructive parallel, and it is more directly analogous to the Salton Sea than any other case on Earth. The Aral Sea, once the 4th largest lake in the world, was drained by Soviet-era irrigation projects that diverted its feeder rivers to grow cotton in the Uzbek desert. By the 1990s, the sea had lost 90% of its volume. The exposed lakebed, the Aralkum, as it is now called, a desert that did not exist 60 years ago, is loaded with organochlorine pesticides, defoliants, and heavy metals from decades of agricultural chemical runoff. Dust storms from the Aralkum carry that chemistry hundreds of miles downwind. Karakalpakstan, the autonomous region adjacent to the former southern shore, has documented some of the highest rates of throat cancer, tuberculosis, and reproductive abnormalities in Central Asia. Anemia rates in women of childbearing age in the region run above 30%. Infant mortality dwarfs the national average. When I describe the Salton Sea playa and its arsenic-laced sediment being lofted into the lungs of children in Imperial County, the Aral Sea is the historical precedent, at catastrophic scale, for what happens when you drain a contaminated basin and let the wind do the rest. The scale is different, the chemistry is comparable, the mechanism is identical, and the lesson, written in cancer wards and infant mortality tables and the dust-choked lungs of Karakalpak children, is that these trajectories do not self-correct. They accelerate. The exposed lakebed gets larger every year the water does not return. The dust sources multiply. The downwind health burden compounds. Nothing reverses without deliberate, expensive, politically difficult intervention. Owens Lake cost $1 billion and a century of litigation. The Aral Sea has cost incalculable human life and remains largely unmitigated. The Salton Sea is somewhere on that continuum, earlier in the curve, with the outcome still undetermined, and the American West is not exempt from this pattern simply because it is wealthier. Wealth buys better hospitals and faster warning systems and paved roads that reduce some surface dust sources. It does not change the physics of outflow-driven dust mobilization. It does not alter the diameter of a Coccidioides arthroconidium at 2 to 5 micrometers. It does not make the soil wetter when the megadrought has been running for 26 years. And as Williams demonstrated with tree ring data reaching back 12 centuries, this drought shows no sign of ending. In 94% of simulations, it persists for at least 23 years beyond its current duration. In 75%, it lasts at least 3 decades more. The Southwest is not emerging from this. It is deepening into it. Every year the drought persists is a year the soil becomes drier, the playas expand, the dust sources multiply, and the valley fever fungus colonizes newly suitable territory farther north and east. The fire dust feedback loop deserves its own moment because it is the compound connection that ties the wildfire crisis directly to the dust crisis through shared mechanism. The National Interagency Fire Center's outlook for July 2026 projects above normal wildfire potential across much of the Intermountain West and the desert Southwest. Fire scar, the burned over ground left behind after a wildfire passes, is one of the most prolific dust sources in the Western landscape. When fire moves through, it does not just burn the vegetation. It destroys the biological soil crust. It combusts the root structure that was anchoring the surface layer. It converts the organic matter that was binding soil particles together into ash that itself becomes loftable particulate. Every acre of fire scar is an acre of newly available material for the next outflow to exploit. The Seven Cabins fire on the Lincoln National Forest in New Mexico, nearly 32,000 acres as of early June, only 57% contained, has produced a scar zone that will be generating dust for years before vegetation can reestablish. And that is one fire. The 2026 season has already burned approximately 2.4 million acres nationally, running nearly double the 10-year average for acreage. Multiply the Seven Cabins scar by the hundreds of fires burning across the West in any given monsoon season, and the feedback loop becomes visible. Drought drives fire, fire creates dust source, dust degrades air quality and delivers pathogens, degraded air quality strains, health systems, and fills emergency rooms. Strained health systems have less surge capacity when the next fire or the next dust storm or the next heat wave arrives. The system eats its own margin. Each event reduces the capacity to absorb the next. I keep coming back to this, the image of a single forcing mechanism pushing multiple levers simultaneously. The drought does not produce dust, or fire, or reservoir depletion, or valley fever amplification. It produces all of them, concurrently, from the same root condition. And the institutional architecture that is supposed to manage the consequences is organized as though they are separate problems, funded through separate appropriations, tracked in separate databases, managed by separate agencies that coordinate through memoranda of understanding, written for a climate that no longer applies. And now this investigation arrives at the question it has been building toward since the opening frame. What does the evidence actually support? Not what does it fear? Not what does it hope? Not what does the most alarming interpretation suggest if you select only the data that confirms the worst case? What does the full body of evidence, including the reassuring data, including the honest uncertainty, including the counterfactuals, actually support? 3 interpretations exist. All 3 can cite published, peer-reviewed data. All 3 are held by credible researchers. The next section presents them fairly, completely, and with the specific observations that would distinguish between them going forward, because the data does not tell us which interpretation is correct. What it tells us is what each one costs if it turns out to be wrong. Part 14. Interpretation 1. The normal monsoon. I owe you honesty here, and honesty means starting with the interpretation that is least alarming and giving it genuine weight, because this interpretation is not wrong. It is not naive. It is held by working meteorologists and experienced desert residents who have lived through decades of monsoon seasons, and it accounts for real data. The interpretation is this: Haboobs are a normal, recurring feature of the North American monsoon. They have been happening in the Sonoran Desert for as long as thunderstorms have been collapsing over dry ground, which is to say for millennia. Phoenix residents who have lived in the valley for 20 or 30 years have seen dozens of them. Some are dramatic, most are brief. The wall rolls through, visibility drops for 10 or 20 minutes, the dust settles, you hose off your car, and life continues. The monsoon season brings them every year between July and September, and every year the metro absorbs them without systemic collapse. And the data supports elements of this framing in ways I need to be fair about. Mark O'Malley at the National Weather Service, commenting on the August 2025 Haboob that knocked out power to 60,000 customers, noted that monsoon rain being very hit and miss, and Phoenix staying drier than surrounding areas, is typical for a monsoon. The word he used was typical. The operational forecasters who work at NWS Phoenix in Tempe have seen hundreds of these events over their careers. They know the pattern, the afternoon buildup, the collapse, the outflow, the dust, the clearing. They issue the warnings. The public heeds them or does not, and the system continues. The particle data, when viewed through the daily average lens, supports this read as well. The 93-event study from 2015 through 2021 found that only about 15% of convective dust events exceeded the EPA daily PM10 threshold. That means roughly 85% of Haboobs, measured across a full 24-hour period, produce air quality readings that stay within federal standards. The peaks are extreme. Nobody disputes that a 5-minute PM10 reading of 9,000 micrograms per cubic meter is dangerous. But peaks are brief, and daily averages are what regulatory compliance is measured against. If you judge by the metric the system uses, most Haboobs are not air quality violations. Andrew Comrie's 2021 analysis in GeoHealth reinforces the moderation of this view. 100 dust storms across Maricopa and Kern counties over 14 years. No consistent correlation between individual storm events and subsequent valley fever case clusters. If the most rigorous event-level study available cannot find the signal, then the argument that any given Haboob directly causes valley fever infections becomes very difficult to sustain. The decadal correlation, Tong's finding that dust frequency rose 240%, while valley fever rose over 800%, is interesting. But correlation at that timescale could reflect shared climate drivers rather than direct causation. Both dust storms and valley fever respond to drought, heat, and land surface changes. so they would trend together even if the storms are not the primary dispersal mechanism for the fungus. The spores may move through subtler ambient winds, through construction disturbance, through agricultural activity, vectors that have nothing to do with a haboob. Under this interpretation, the current conditions, the drought, the heat, the exposed soil, are within the range of natural variability for the desert Southwest, amplified by climate change but not fundamentally transformed. The Williams reconstruction shows multiple severe droughts in the tree ring record before human emissions were a factor. The late 1500s megadrought was comparable in severity. The desert has been this dry before, within the span of recorded dendrochronology. It produced dust before. The population is larger, which means more people are exposed, but the per-event hazard profile has not demonstrably changed. What has changed is attention, more cameras, more social media, more viral time-lapse footage, making events visible that previous generations experienced and moved on from without documentation. I want to be clear about something. This interpretation is defensible. It is not a straw man I am setting up to knock down. A reasonable person, looking at the evidence assembled in this investigation, could conclude that the Southwest is experiencing a severe but not unprecedented drought, that haboobs are a normal monsoon hazard requiring standard precautions, and that the valley fever surge is primarily a function of improved diagnostic testing, increased clinician awareness. The UA Valley Fever Center researchers have been pushing for more testing for years, and population growth in endemic areas rather than a fundamental shift in pathogen behavior or dispersal. That conclusion would not be irrational. It would not ignore the data. It would weigh the data differently. But it would require setting aside three things that I cannot set aside. The 240% increase in dust storm frequency is not explained by observation bias. Tong controlled for that. The 42% human attribution of the megadrought means the current drought is not within unforced natural variability. It is a hybrid, and the forced component is increasing. And the institutional classification gap, 232 deaths counted against roughly 45, means the system is not seeing its own failures accurately. Those three data points are what pull me toward the second interpretation, and I think the weight of the published evidence pulls there too. Part 15, Interpretation 2, the intensifying trend. The second interpretation is the one the published peer-reviewed literature most directly supports, and it is held in various forms and with various emphases by the researchers whose names have appeared most frequently throughout this investigation: Williams, Tong, Goris, Crooks. It is the interpretation that takes the trend data at face value and asks what the trend implies for the systems currently in place. The interpretation is this: the American Southwest is not experiencing a normal drought with normal dust storms and a normal monsoon hazard profile. It is experiencing a structural shift in baseline aridity that is intensifying the frequency, scale, and health burden of dust events on a trajectory that existing management systems have not caught up to. The trend line, not any single storm, is the real story. Start with Tong's 2017 finding. Dust storm frequency increased 240% from the 1990s to the 2000s. That is not a fluctuation, that is a step change, and it coincides precisely with the onset of the megadrought that Williams dated to the year 2000, the driest 22-year period in over 1,200 years, with 42% of the deficit attributable to human-caused warming. The dust frequency increase is a direct physical consequence of the soil moisture deficit. Drier soil means more loftable material. More loftable material means more dust events when the outflow winds arrive. The mechanism is not speculative. It is basic soil physics confirmed by observational data. Valley fever incidence is rising in parallel. Arizona hit 14,763 reported cases in 2024. California hit roughly 12,637, both records. The Williams and colleagues estimate in JAMA Network Open suggests true symptomatic infections run 10 to 18 times higher than surveillance captures. And Morgan Goris's modeling at Los Alamos projects the endemic zone more than doubling by century's end under high warming scenarios, pushing into states that have never seen the disease. The American Lung Association's 2026 State of the Air report ranked the Phoenix Metro 4th worst nationally for ozone and 15th worst for year-round fine particulate, deteriorated from 20th the prior year. El Paso surged in the rankings after spring 2025 dust storms pushed the Chamizal monitor, operating since 1999 to 4 of its 5 most polluted days ever recorded in a single March week. The direction across the region is consistent and unambiguous. The air quality is getting worse, not better, despite decades of Clean Air Act regulation, targeting industrial and vehicular emissions. And the driver of the deterioration is not those traditional sources. The driver is dust, natural in origin but amplified by human-caused drought, human-caused land disturbance, and a warming atmosphere that is pulling moisture from the soil faster than precipitation can replace it. Tong's 2023 death study is the capstone of this interpretation. 232 dust deaths in 11 years, 5 times the official count, hidden by classification artifacts in the Federal Hazard Database. The deaths are not increasing because the storms are getting deadlier on a per-event basis. The deaths are increasing because the storms are getting more frequent. The population in their path is getting larger and more urbanized. The exposed surfaces are getting more productive as the drought deepens and playas expand. And the classification system that would make the full toll visible to policymakers is still filing a significant fraction of dust fatalities under high winds and thunderstorm wind. The trend compounds at every level. Under this interpretation, the correct response is not emergency preparation for a single catastrophic event. It is systemic adaptation to a baseline that is permanently shifted, or more precisely, that is still shifting, in a direction that every model projects will continue for decades. The specific adaptations are identifiable. Dust storm warnings need to be issued with longer lead times, and the warning products need to be integrated with health alerts, not just transportation alerts. Ryan Heinzman's dust storm scale at ASU is an attempt to classify these events the way the enhanced Fujita scale classifies tornadoes, giving emergency managers graduated response triggers instead of a binary warning or not system. Valley fever surveillance needs to be made reportable in all 50 states, not 28. A traveler who inhales Coccidioides spores in Tucson and develops meningitis in Columbus, Ohio, should appear in the national surveillance picture. Currently, that case may be diagnosed, treated, and resolved without ever registering in the Federal Valley Fever dataset, because Ohio is not a reporting state. Hospital surge planning in Maricopa County, Pinal County, and Pima County needs to incorporate dust event triggers alongside heat wave and wildfire smoke triggers, recognizing that these hazards are correlated, not independent, and that a dust event during a heat wave produces a patient surge profile different from either hazard alone. Highway engineering in known dust corridors, I-10 mileposts 175 through 215, the Lordsburg Playa stretch into New Mexico. The Eloy to Casa Grande Basin needs physical mitigation beyond advisory signs. Wind fences, surface stabilization of adjacent land, automated visibility detection systems that trigger variable speed limits or corridor closures before the first car enters the wall. The technology exists. What does not exist is the funding priority, because the death toll that would justify the expenditure is filed across multiple databases in multiple agencies under multiple hazard categories, and no single agency sees the full number. And the monitoring gap, the absence of any integrated real-time dashboard tracking dust concentration, heat index, fire smoke, respiratory ER admissions, hospital bed availability, and valley fever exposure risk as components of a single compound hazard picture needs to be closed. The agencies managing individual components of the dust heat fire health complex cannot see the system-level risk that emerges when their individual hazards interact. Each agency is managing its piece competently. Nobody is managing the interaction. This interpretation does not require catastrophism. It does not predict a mass casualty event, this summer or any specific summer. What it says is that the baseline is shifting. The trend is documented in peer-reviewed literature. The adaptations are identifiable and their costs are estimable. And the cost of continued delay is measured in the growing gap between Tong's 232 deaths and NOAA's official count of roughly 45. a gap that exists only because nobody assembled the full picture until a researcher at George Mason University decided to cross-reference the databases that the institutions keep in separate filing cabinets. Part 16, Interpretation of 3, I, the compound convergence. The third interpretation takes every evidence thread in this investigation, every data point, every mechanism, every named source, every historical precedent, and asks the question that the data itself raises but cannot answer. What happens when they all arrive at once? I want to present this carefully because it is the most alarming interpretation and the one most susceptible to being mistaken for prophecy. It is not a prophecy. It is not a prediction. It is a scenario, a physically grounded scenario in which every individual component has a documented precedent in the evidence I have assembled, but the simultaneous combination of those components has never been observed at the scale and population density the current conditions would produce. And I need you to hold the distinction between this has not happened and this cannot happen, because the evidence I have presented over the last 2 hours demonstrates that those are very different statements. The scenario begins on a mid-July afternoon in 2026, a 2011 scale Haboob, 5,000 feet tall, 100 miles wide, PM10 concentrations approaching 2,000 micrograms per cubic meter at the hourly peak, strikes the Phoenix metropolitan area during extreme heat. The outflow has crossed fire-scarred terrain and drought-exposed playas on its path north. The dust carries the standard mineral particulate load, plus, in focal patches, Coccidioides, arthroconidia from undisturbed desert soil, and from construction zones where grading has exposed subsurface fungal reservoirs that no survey has mapped. The Haboob reaches the metro. Visibility drops to 0 on Interstate 10 and Interstate 17. Multi-vehicle pileups occur in the known kill zones. Sky Harbor International Airport, Paris, 11th busiest in the nation, more than 1,000 flights per day, issues a ground stop. The power grid, stressed by extreme heat demand and now hit by 70-mile-per-hour gusts, fails across sections of the metro. More than 60,000 households lose electricity and with it air conditioning in ambient temperatures exceeding 115 degrees. The nearly 10,000 unsheltered people in Maricopa County are breathing unfiltered dust at unshaded ground level temperatures. Emergency departments begin receiving the first wave within hours. Asthma exacerbations, COPD flares, cardiovascular events triggered by the dual stress of particulate inhalation and extreme heat acting on the same cardiovascular system simultaneously. Motor vehicle trauma from the highway pileups. Heat-related illness from people who lost air conditioning or who were outdoors when the storm hit and could not find shelter. The junk data from JAMA Network Open tells us to expect a 6% increase in asthma emergency visits within 48 hours, a 6% rise in culture-negative pneumonia and congestive heart failure within a week, and a 13% spike in crash-related visits on the storm day itself, applied to a metro of 5.2 million people with a baseline adult asthma prevalence of 9.8%. Roughly 550,000 to 600,000 people. With pre-existing airway vulnerability, even a 6% surge represents hundreds of additional patients arriving at emergency departments whose baseline capacity I have documented and whose surge margin I cannot confirm, because the data is not public. And this is happening on top of whatever the normal summer patient volume already looks like. July in Phoenix is already the busiest month for heat-related emergency visits. The hospitals are not starting from idle. They are starting from a summer baseline that is itself elevated. The second wave arrives 2 to 3 weeks later. People who inhaled Coccidioides spores during the storm begin presenting with fever, persistent cough, crushing fatigue, and chest pain that mimics pneumonia. Most will be initially diagnosed as bacterial pneumonia by physicians who may not think to test for valley fever, even in Arizona, where clinician awareness is higher than anywhere else in the country. They will be prescribed antibiotics that do nothing. Days will pass. Some patients improve as their immune systems contain the infection. Some do not. 5 to 10% of symptomatic patients develop chronic pulmonary coccidioides that can persist for years, and roughly 1% disseminate, the fungus escaping the lung through the bloodstream to bone, skin, or the meninges surrounding the brain. For those patients, treatment is measured in months to lifetime. The cost runs from hundreds of thousands to over $1 million per case, and the outcome is uncertain even with the best antifungal therapy. The Valley Fever Center at the University of Arizona, Galgiani, Donovan, their team has the clinical expertise to manage even severe disseminated cases. But the patient volume in this scenario, potentially thousands of simultaneous exposures across a single metro, producing a wave of symptomatic illness 2 to 3 weeks later that lands on the same emergency departments still managing the aftermath of the acute dust event, would represent a diagnostic surge unlike anything the infectious disease infrastructure has been asked to absorb. Every day between symptom onset and correct diagnosis is a day the fungus has to establish itself more deeply, reducing treatment efficacy and increasing the probability of chronic or disseminated disease. And the system managing all of this is fragmented across agencies that do not share real-time data, do not operate from a unified incident command for dust events, and do not have publicly available ICU capacity dashboards that would allow advanced assessment of surge margin. Every element of this scenario has happened. The dust height, the particle concentration, the wind speed, the power outages, the highway fatalities, the airport closures, the ER surges, the valley fever exposures, the heat-related casualties, all documented, all in the dossier. What has not happened is all of them occurring simultaneously to this population at this density under these drought conditions. And the question the evidence raises, not answers raises, is whether the absence of that compound event in the historical record means it is unlikely, or whether it means the conditions required to produce it have only recently assembled. I do not know the answer, neither does anyone else, but the preconditions are measurably closer to alignment in our 2026 than in any previous monsoon season I can identify. Part 17, What We Know and What We Don't. I want to separate this cleanly, because the line between confirmed fact and open question is the most important line in this entire investigation. Getting it wrong in either direction, claiming certainty where uncertainty exists, or claiming uncertainty where the evidence is clear, would undermine everything the last 2 hours have built. What we know. And I want to be precise here, because every claim in this list is backed by a specific publication that I have named in this investigation, and you can verify any of them yourself. The Southwest megadrought is the most severe in over 1,200 years and is being amplified by human-caused climate change, responsible for roughly 42% of the soil moisture deficit. That is confirmed by peer-reviewed Attribution Science and Nature Climate Change, lead author Park Williams. Dust storm frequency has increased 240% between the 1990s and the 2000s. That is confirmed by Tong and colleagues in Geophysical Research Letters. Dust kills more Americans than official statistics report, 232 versus roughly 45 over an 11-year period. That is confirmed by cross-referenced federal databases in the Bulletin of the American Meteorological Society. Valley fever is surging to record levels in both Arizona and California, with true symptomatic burden estimated at 10 to 18 times the reported number. That is confirmed by CDC surveillance data and modeling in JAMA Network Open. The Salton Sea playa is contaminated with agricultural chemicals and is measurably harming the respiratory development of nearby children. That is confirmed by USC, UC Irvine, and USGS investigations. A major Haboob can deliver PM10 concentrations 60 times the daily safety standard in a 5-minute window. That is confirmed by EPA station. Data analyzed by Raman and Egar. What we don't know, and this list matters as much as the first, because the gaps define where the investigation goes next. We do not know whether a standard monsoon Haboob, as opposed to a sustained scouring event like the 1977 Kern County storm, can deliver enough Coccidioides spores to trigger a detectable case cluster. Comry's data says probably not for conventional outflow events. The current data says deep disturbance absolutely can. The threshold between those two regimes, the wind speed, the duration, the depth of soil disturbance, the density of fungal colonization in the source area, this is undefined. Nobody has quantified it. That gap is the single most important unanswered question in dust health science for the American Southwest, and closing it would require a field campaign that no agency has yet funded. We do not know the precise distribution of coccidioides in the soils of the Phoenix metropolitan airshed. No comprehensive survey has been conducted. The fungus is focal, one patch loaded, the next patch clean, and without a spatial map, we cannot predict which outflow paths carry the highest biological risk and which carry essentially none. William Sprigg at the University of Arizona has advocated for dust forecasting systems that would incorporate soil data, but the soil data itself does not exist at the resolution needed. We do not know current ICU occupancy rates or real-time surge capacity at Maricopa County hospitals. That data is not publicly available in a form that community members, researchers, or even county emergency planners can access in real time. I looked for it, I could not find it. The bed counts I reported, Banner University Medical Center at roughly 700 to 755 beds, Valleywise at 555, approximately 13,300 total staff beds statewide are the structural figures. But how many of those beds are occupied at any given moment, how many ICU beds are available, what the staffing ratio is on a particular July afternoon, that picture is opaque. And in a compound event, the difference between having 200 available ICU beds and having 20 is the difference between a managed emergency and a catastrophe. We do not know whether the 2026 monsoon will produce dust events at or above the 2011 benchmark. That depends on convective dynamics that are inherently chaotic beyond a forecast horizon of a few days. The CPC can tell us the monsoon will likely be near to above normal. It cannot tell us whether the specific storm that collapses over the specific basin at the specific hour will produce a 5,000-foot wall or a minor dust plume that dissipates over open desert. And we do not know the full chemical composition of Salton Sea playa dust. The CARB-funded analysis by SDSU and Scripps is still underway. The health effects are arriving ahead of the characterization. That is a gap with direct consequences for the 100,000 people living downwind. What would tell us? The specific data points that would distinguish between the three interpretations are identifiable, trackable, and in most cases publicly available. And I want to name them precisely, because this is the part of the investigation that converts a 2-hour documentary into an ongoing observation framework. If the 2026 monsoon season produces Haboob frequencies at or above the Tong 2017 trend line, 48 or more significant dust events across the Southwest, and valley fever cases in Arizona exceed the 2024 record of 14,763 by a statistically significant margin after accounting for testing volume, then interpretation 2 is strengthened. The trend is not a statistical artifact. It is an acceleration with a physical driver. If a compound dust-heat fire event produces simultaneous multi-system strain in a major metro, highway closures and airport ground stop, and mass power outage and ER surge from dust and ER surge from heat, overlapping within the same 72-hour period, and the institutional response reveals capacity gaps that existing surge plans did not anticipate, then interpretation 3 moves from scenario to documented precedent. That would not mean interpretation 3's worst case has arrived. It would mean the compound architecture is real and can no longer be dismissed as hypothetical stacking. If the monsoon season passes with dust frequencies within historical norms, closer to the long-term average of 20 events per year than the elevated 48 hours, and valley fever cases in Arizona and California plateau, or decline despite the El Nino wet-dry whiplash, then interpretation 1 gains ground, and the trendline analysis requires honest revision. That outcome would not invalidate the megadrought or the 240% frequency increase. Those are retrospective data, not forecasts. But it would suggest that the relationship between preconditions and outcomes is less linear than the trend extrapolation implies. The data will come, The monsoon will begin within weeks. The U.S. Drought Monitor will update every Thursday. The ADHS Valley Fever surveillance reports will publish on their regular schedule. The NWS warning products will accumulate in the archives. The Air Now PM10 readings from EPA monitoring stations across the Phoenix metro will be available in real time for anyone who wants to watch. And either the preconditions I have documented will manifest in the compound patterns that evidence suggests are increasingly likely, or they will not. Either way, the structural evidence assembled in this investigation, the trend lines, the mechanisms, the surveillance gaps, the institutional fragmentation, the 42% human attribution, the 1,200-year drought, does not expire with the 2026 monsoon season. It describes a condition that will apply to 2027 and 2028 and every summer that follows until the megadrought breaks or the systemic adaptations described in Interpretation 2 are implemented. And Park Williams, who knows this drought better than almost anyone alive, says it is extremely unlikely to end in one wet year. The Drought Monitor says the drought is not breaking. The reservoir data says the system is at 35% capacity and falling. The atmosphere says the soil is getting drier. The epidemiological data says valley fever is setting records. And the monsoon season starts in 3 weeks. On part 18, the quietest data point, I want to end somewhere specific, not with a grand statement about the future of the Southwest, not with a warning calibrated to produce anxiety, with a place and with a commitment. There is a stretch of Interstate 10 between mileposts 175 and 215, south of Casa Grande, Arizona, where the desert opens up flat to the horizon in every direction. There are no buildings along most of it. There are no trees tall enough to break the wind. There is just pavement and sky and the cracked alkaline surface of the Sonoran Desert, stretching to the Picacho Mountains on one side and the open basin on the other. 36 people have died on Arizona highways in dust-related crashes over the past decade, and this corridor has taken more than its share. If you drive that stretch this July, and millions of people will, because it connects Phoenix to Tucson and both cities to the rest of the country, you will see the dust before you see anything else. On the days when the monsoon fires, a brown line on the horizon, low and solid and moving faster than it looks. And in the seconds between noticing that line and being swallowed by it, seconds that shrink as you close the distance at 70 miles per hour, you will have a decision to make. Pull aside. Turn off your engine. Turn off your headlights so the car behind you does not follow your taillights into a wall of zero visibility. And wait, that is the individual scale version of what this entire investigation has been about. A decision that the evidence demands before the event arrives. And the same logic scales all the way up, from a single driver on a single highway to the county emergency manager in Maricopa, reviewing hospital surge plans that may not account for simultaneous dust and heat and fire smoke, to the state epidemiologist at ADHS tracking valley fever through a surveillance system designed for a pathogen that spreads person to person rather than atmosphere to population, to the federal water manager at Reclamation, watching Lake Mead approach a number that the original engineering specifications said was impossible. The evidence is assembled, the mechanisms are documented, the trends are quantified, the gaps are named, and the monsoon begins in weeks. I do not know what the summer will bring to the desert Southwest. I know what the preconditions say it can bring. I know that the gap between what the data says is physically possible and what the institutions are currently prepared for has not closed in any year since the megadrought began. By every metric in this investigation, dust frequency, valley fever incidence, air quality rankings, reservoir levels, soil moisture, fire season intensity, that gap is widening, not narrowing. This channel will be watching. When the Drought Monitor updates on Thursdays, we will read it. When the NWS offices in Phoenix and Tucson and El Paso issue dust storm warnings through the monsoon season, we will track the frequency and severity and compare it to Tong's baseline. When the ADHS publishes its valley fever surveillance data through the summer, we will be here with the context to explain what the numbers mean and the honesty to tell you when they mean something different from what we expected. If you have watched to this point, you are part of why this channel exists. The people in the comments, the nurses in Phoenix, the emergency managers in Pinal County, the truck drivers who have been inside the wall on I-10, the parents near the Salton Sea who watch their children use inhalers, you are the reason this investigation is 2 hours long instead of 10 minutes. Because this community does not want the headline. It wants the evidence. And the evidence, as always, is where we start. The dust is not waiting, neither are we.